Hello, this is Dr. Kavita from SNS College of Technology. In this session, I am going to take about the plate girders. So here, nowadays, we are using the railways everywhere. So since the India's the strongest point is the railway. So if we are comparing with the other countries, we are having the broad network in railways. So mostly the railways which are crossing from one state to the other state. So mostly the railway tracks are maybe the on the bridges. So in that places we are using using the plate girders. So therefore, so this is the actually this is a one type of steel beam, and mostly it is used for constructing the bridges. And also the reason for using this plate girder is it is suitable for carrying heavy loads. So here, if you are increasing the depth and the stiffness when compared to the other normal beams, so we can go for longer spans also. So therefore, the railway, when the trains are moving on the railway track, so there may be the chances of moving loads and also the live loads. So due to this, there may be the chances of failures if you are providing the normal beams. So in that places, we are providing the plate girders. So here you can see this. So this is the one of our famous tourist spot in Tamil Nadu, that is a Ooty railway. So you can see this. So this is a piers which is constructed by RCC, and here the whole railway tracks are constructed by means of the steel beams. So here this steel beams is nothing but the plate girder. So here you can see this. Here this is a railway tracks, and the thing which is provided below this railway track is nothing but a steel plate girders. And also not only for railways, so here in highways also we are using this plate girders, and also for industrial structures. So when the places where heavy loads are acting on the industrial structures, in that places also we are using the plate girders. So therefore, if you are taking this, this is a structural element which is used in mostly in bridge construction and also in few places of industrial buildings, the places where we need the large structures. So if you are taking this consists of a plates in a form of deep and rectangular section which is capable of supporting heavy loads. And also if you are taking this the advantage of this plate girder is nothing but there will be the high strength to weight ratio, and also it will provide the very easy flexibility in designing. So what are the plate girders? So if you are taking this is a built up beam. So if you are taking the beam, there will be the one section may be there. So mostly for beam we are providing the I section. So if you are providing more than one section, that is if you are providing the stiffness, everything, so it will become a built up beams. So this is nothing but a built up beam, and it is mainly used to design to support the massive vertical loads over a long span. When we are going for the railway tracks, there will be the longer span will be there. In that places, instead of going for RCC bridges, these bridges are very useful. And also the places where more bending moments are there, and also it will resist the movement very easily. So this is the composed of two flanges, that is a top flange and bottom flange, and it is welded together, either welded, mostly the welding we are using to the web plate. So this if you are seeing that the components, so this is the actual plate girder, and this is a top flange, and this is a bottom flange, this is a web plate. So here when the loads are the heavy loads are there, here we are providing some stiffness. So there may be the chances of failures of this web. So in that places we are providing the stiffness. So here this is the horizontal stiffness, and this is the vertical stiffness. So here mostly we are using the welding for doing all the attaching all the components. So if you are taking this, the main reason for providing the thing is web, it will take the resist the shear forces. And if you are taking the flanges, the top and bottom flanges, the top flange will be the compression, it will take the compression, and the bottom will be the tension. And the stiffness, the main reason for providing the stiffness, it will prevent the buckling, and also the here it will provide in vertical and horizontal types. So we will see the components one by one. So here this is a web to resist the, mainly it resists the shear forces. This is a vertical plate in the form of the main body of the girder. So here it may be the stiffener, it may be slender. So in that places we are providing the stiffness to prevent the buckling. So the flanges. So this is a compression flange, and this is a tension flange. So it will take care of the bending moments. So like that the webs will take care of the shear force, and the flanges are taking care of the bending moments. So there may be the chances of bending of the flanges may be there. So while we were designing, so we have to take care of designing the flanges. So here the stiffness, whenever this depth of the plate girders, that is the depth of the web is increased, there may be chances of buckling. So in that places, to prevent the buckling under the load, we are providing the stiffness. So if you are taking that the vertical stiffness, we are calling that as a transverse stiffness. So it is positioned in vertical manner, and it will take the resist shear buckling, and also support the bearing at supports. So whenever the concentrated loads are acting, it will take care of. And if you are taking this is a longitudinal or horizontal stiffness. It is provided in horizontal manner. So whenever the depth of the web is more, there may be the chance of local web buckling. Okay, so here if you are taking this, the vertical stiffness will take care of the shear buckling, and the horizontal or longitudinal stiffness will take care of the local web buckling. So and also other some stiffness we are providing. So end stiffness, that is end bearing stiffness. So whenever we are placing the plate girders on the piers, there may be the chances of the failure. So if you are providing the end bearing stiffener, it will transfer the load very easily. And some also the connection elements we are providing, either bolts, welds and rivets we are providing. So mostly nowadays we are going for the welding. And also this is a critical structural integrity. So therefore we have to take more care while we were designing this connections. So here you can see this. So this is a plate girder, and here this is a industrial steel structure. So this is a main plate girder. Here they were providing the vertical stiffness, and here this is a place where these beams are going to be resist on some column, and this in this place we are providing the bearings, and also to take care of the sway moment, we are providing the bracings also. So if you are taking the types of the stiffness, the vertical stiffness may be end stiffness, or it may be intermediate, and some it may be a continuous and discontinuous. So everything to take care of the buckling of the beams. So and also if you want to place more plate girders in these places, to joining two plate girders in a place, we are providing the splice plate. So mostly the splice plate will be provided on flanges and also the web plate also. So it will transfer the loads to the support. And taking the types of the plate girder, so the connected connections may be by rivet or bolted or welded. So here if you are taking the welding, we are providing the rivets, and in general the web carries the 90% of the shear acting on the riveted plates. The angle section riveted to the flange stabilizes the connection between the web and the flange. So the rivet must be designed to withstand the horizontal shear. And also taking this a welded plate girder. So this is a most commonly type of used plate girder, and it is very easy to manufacture, and it will give the more efficiency. So this is the sections mainly used in construction of the bridges. The plate girder bridge is extremely stiff, and it can withstand extremely high loads while resisting the lateral moments. So this action is visible on the railway bridges. So the welded plate girder we are using uh, used to create the box type girders also. The main advantage are it will withstand the heavy loads, and it have a great stability, and also it resists the fatigue failures also. When compared to the truss bridges, this is very somewhat simpler to do the construction, and also the maintenance also very easy, and also very easily the time to construct these bridges are somewhat less. So if you are taking the disadvantage, so for very large spans, there is some limitations for spanning. So if you are going for very large spans, yeah, this is not preferable. And yeah, if you are taking that architectural appearance, it will not be somewhat less when compared to the truss bridges. And also some places the placing of plate girder is somewhat difficult, and also we have to do the design very strictly, and we have to follow the codal provisions in strict manner. So then only we can avoid the failures. So in last session I have explained some plate girder which is collapsed during the construction itself. So therefore we have to make the proper design procedure for designing this bridges. So the applications in roadway, railway bridges, box and beam bridges, cranes, and lifting the structures in oil and gas firms, and ships and gantries. So thank you for listening this video.